Hello everybody, welcome into another lesson. So today we are going to start talking about arithmetic sequences. So arithmetic sequences are actually fairly nice to deal with. Unlike the past sequences we've dealt with where they've been all over the place, an arithmetic sequence will be the next lesson, but arithmetic sequences have a common difference between each term. So let's say we have this sequence here. We have 10, 8, 6, 4, 2, and it just keeps going infinitely. If you notice, it decreases by 2 between each term. It keeps on the same progression, decreasing by 2 each term, and it doesn't change. Well, there is a way to find the explicit formula for the nth term of an arithmetic sequence. To find that formula, a sub n, you're going to take your very first term plus the quantity of n minus 1 times d, where d is your common difference, and n's the number of the term you're on. So what if we tried to find an explicit formula for this particular sequence? Well, a sub n, that's going to equal my a sub 1, which in this case, my first term a sub 1 is 10, plus we have n minus 1, right? We don't know what n is because that's the number of term you're currently on, that you're trying to find. But we've determined the common difference is -2. We have determined that. So if I put in 1 for n, 1 minus 1 is 0, that would give me back my first term being 10. That's one way to test it. But we want to simplify this. So what you're going to have now is 10, and then you take that -2 and distribute it. So you'll have 10 minus 2n, -2 times -1 plus 2, which would finally end up giving you 12 minus 2n. So you end up getting that for this particular arithmetic sequence, the formula is a sub n equals 12 minus 2n. Once you do your distribution, you'll start with this formula, and you'll work to simplify it by distributing, where you have only one constant term and the n variable term. And I'll leave that formula up for now. So let's do another one here. Let's say I have another sequence, 4, 9, 14, 19, 24, ... So I have a sequence here, 4, 9, 14, 19, 24, and it just keeps going and going. If you look between each and every single term of the sequence, it goes up by 5 every term, right? So we've identified our common difference, d, to be 5. We know our common difference is 5. Our very first term is 4. A sub 1 is 4, we actually have enough to go ahead and find the formula for the sequence. So a sub n is going to equal my a sub 1, which is 4, plus the quantity of n minus 1 times my common difference of positive 5. Now we just need to simplify this, so we'll have 4 plus, we'll distribute that 5 into this quantity, plus 5n minus 5, which when we simplify this would end up giving me 5n minus 1. So I get the formula for this arithmetic sequence to be a sub n equals 5n minus 1. And these are actually very nice to deal with. All right. So let's see, I have -24, -16, -8, 0, positive 8, and it just keeps on going and going. So I have this sequence here, negative 24, negative 16, negative 8, 0, 8, and it just keeps on going and going. If we look between each and every single term, it goes up by 8. We're increasing by 8. So my common difference is going to be 8. And then we have our very first term, which is a sub 1, that's negative 24. Now that we've identified our common difference and our first term, we have enough to find the explicit formula. So a sub n is going to equal my a sub 1, which is negative 24, plus that n minus 1 times that common difference d of 8. And now we just need to simplify this. So we'll have negative 24 plus distributing that 8 into the n minus 1, that'll be plus 8n minus 8, which would simplify into 8n minus 32. So the explicit formula for the nth term of this sequence is going to be a sub n equals 8n minus 32. All right. Let's see, we have 3.7, 4.3, 4.9, 5.4, 6.0, and it just keeps on going and going. So we have 3.7, 4.3, 4.9, 5.4, and 6.0. Yes, you actually can get fractions and decimals in an arithmetic sequence. If you look between each and every single term, it goes up by 0.6. So the common difference in this case is 0.6. Your very first term, a sub 1, is 3.7. So we've identified the common difference in the first term. We have enough now to find the general formula, the explicit formula. So a sub n is going to equal that a sub 1, which is 3.7, plus the quantity of n minus 1 times that common difference of 0.6. All right, now we can simplify by distributing that 0.6 into the quantity. So this will turn into 3.7 plus 0.6n minus 0.6, which the final answer, simplified form, would be 0.6n plus 3.1. So we end up getting that a sub n equals 0.6n plus 3.1 for the explicit formula for this arithmetic sequence. Alright, now let's throw a couple of these at you. What if I had something like the natural log of 1, natural log of 2, natural log of 3, natural log of 4, natural log of 5, and it just keeps on going and going and going? Well, natural log, you're not going to get a common difference between each of these. This is definitely a sequence, but it's not arithmetic. This is not an arithmetic sequence. In order for it to be arithmetic, it has to have a common difference, and there is no common difference between each term. It varies by, if you put these into the calculator, you're going to get different decimal approximations that are way off from each other. So this doesn't have a prayer of being arithmetic. How about this one? We got 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and it just keeps on going and going and going. Well, okay, if it helps you simplify this, you'll end up getting 1, 4, 9, 16, 25, and it'll just keep on going and going and going. Well, there is no common difference, right? You have a different amount of numbers between each term, so this is not an arithmetic sequence. In order for it to be arithmetic, it must have a common difference. That's the only way that it can be an arithmetic sequence. Otherwise, you just have a sequence. Alright, so there's that way of doing it. Now, we're going to do a few easy exercises, then we're going to do a few harder ones for finding the formula for a sequence. So, let's say you start out, you're given a sub 1 equals 3. The common difference is actually a sub 1 equals 1. The common difference is 3. I almost had that backwards. So sometimes you may be given the first term and a common difference. That's actually easy. They practically handed the answer to you for how to find the formula for an arithmetic sequence. You can just take your a sub n equals your a sub 1, which is 1, plus the quantity of n minus 1, times your common difference, which is 3. This will simplify into 1 plus 3n minus 3, which means your final answer should be 3n minus 2. A sub n would equal 3n minus 2. If they give you the first term and a common difference, they've practically given you the answer already. All you have to do is take those and plug it into the formula. Now, some of these we're about to do today won't be quite that simple, but there's ways to deal with it too. What if they gave you something like a sub 1 equals 100, d equals negative 8? So they've given you, for this particular arithmetic sequence, the first term's 100 and d equals negative 8, the common difference. Once again, they've handed you the answer practically. All you're going to have to do is take that a sub n, set it equal to this formula. A sub 1 in this case is 100, plus that n minus 1 times your common difference of negative 8. Now we can simplify. This will turn into 100 minus 8n plus 8, which for your final simplified form would end up giving you 108 minus 8n. So the explicit formula for the nth term of this sequence would end up being 108 minus 8n. Let's do one more easy one, and then we're going to make it a little bit harder. Alright, let's see. We have a sub 1 equals 0, and then we're given that the common difference is negative 2/3. Yes, you can have fractions and decimals as a common difference. That is entirely possible. So again, you're given the first term and you're given the common difference. Well, let's put that into the formula. So a sub n is going to equal my a sub 1, which is 0, plus that n minus 1 times my common difference of negative 2/3. Well, we can simplify this. That 0 we don't even got to worry about, because 0 plus anything is that thing. So this will turn into negative 2/3 n plus 2/3, which you can leave it that way, or you could write it as 2/3 minus 2/3 n, however you prefer to write it. If you Want to have the n term first or have your positive term first? Either answer is acceptable. But you'll end up with negative 2/3 n plus 2/3 or 2/3 minus 2/3 n. That would be the formula for this arithmetic sequence. So up till now they've held our hand. They've given us the first term and the common difference. Now I'm going to make this mildly harder. Let's do this. So let's say they give you the first term is 5. We're given the first term, but they don't give us the common difference. They give us that the fourth term is 15. Alright, so how in the heck are we going to deal with that? We have the first term is 5, the fourth term is 15. We don't know the common difference. Believe it or not, you're going to have to pull out a system of equations trick. So you need to take each of these values here, okay? Start with your a sub 1. So in this case, a sub 1 equals a sub 1, which is going to be a sub 1 plus the number of term I'm on is 1 minus 1 times d. No, I didn't want to do that. So a sub 1 equals 5, but we can use this as a system of equations because we're trying to find a sub 4, which is going to equal my a sub 1 plus, this tells me that n in this formula is the number of term I'm on, so this would be 4 minus 1 times d. Well, a sub 4 they give us is 15. That equals my a sub 1, which is 5. Plus, now if we simplify that 4 minus 1, that's 3 times d. All I need to do now is solve for my common difference, and then I can get a general formula for the arithmetic term of the sequence. So this would turn into 3d plus 5 equals 15. So 3d equals 10. My common difference is 10/3. So I get a common difference of 10/3. Now that I know both a sub 1 and my common difference by using the fourth term to find that common difference, I can actually find the formula for the general term of the sequence. So a sub n would equal my a sub 1, which is 5, plus n minus 1 times my common difference of 10/3. So let's simplify this by distributing. You'll have 5 plus 10/3 n minus 10/3. Well, you'll still have 10/3 n for sure, but 5 minus 10/3, that's the same as 15/3 minus 10/3. That'd be plus 5/3. So the explicit formula for the nth term of this sequence is going to be a sub n equals 10/3 n plus 5/3. So that is how you would find the explicit formula when you're given the first term and some other term. And then, of course, with this explicit formula, you could find any term of the sequence you want once you find that. Let's do another one similar to this. Alright, let's say we have a sub 1 equals negative 4, a sub 5 equals 16. So again, we don't know the common difference. We just know that the first term is negative 4, and then we know the fifth term is 16. Well, we know part of this already. We know a sub 1 is negative 4. Now, what we need to do, since we're given the first term, we need to take that fifth term and put that into the formula. So this is going to read a sub 5, since we have the fifth term, is going to equal my a sub 1, which is negative 4, plus, this is the fifth term, so 5 minus 1 times d. Well, a sub 5 is 16, so 16 equals negative 4 plus 5 minus 1 is 4 times d, so we would have 16 equals negative 4 plus 4d, which we can rearrange this, make this 4d minus 4 equals 16, so 4d equals 20, which means d, being my common difference, is 5. Now I've just found my common difference of this arithmetic sequence to be 5. Since I know that and my first term now, I can find the explicit formula for the general nth term of the sequence. So a sub n equals my a sub 1, which is negative 4, plus the quantity of n minus 1 times my common difference of 5. Then I can just simplify this by distributing that 5 through the quantity. So this would be negative 4 plus 5n minus 5, which should simplify into 5n minus 9. So the general formula, the explicit formula for the nth term of this sequence is going to be a sub n equals 5n minus 9. And then from there you could find any term of the sequence you wish. Alright, we're going to make it even harder, because you're not even going to be given the first term or the common difference this time. What if you're given a sub 3 equals 94, and then you're given another term, a sub 6 equals 85. So this time we don't know the first term or the common difference. We only know the third term, which is 94, and the sixth term, which is 85. This is where we need to get into a system of equations. Let's take each of these formulas, let's take each of these terms, write out the formula separately for them, okay? So a sub 3 is going to equal my a sub 1, which we don't know yet, plus, since we're dealing with a third term, we'll put in 3 for that n, so that would be 3 minus 1 times d, which means that a sub 3 in this case was going to be 94 equals a sub 1 plus 2d once we simplify this. Now what about for our sixth term? So a sub 6 is going to equal a sub 1 plus, now since we're dealing with the sixth term, we'll put in 6 for n, so that'd be 6 minus 1 times d. Well, a sub 6 was 85, that's going to mean 85 equals a sub 1 plus 5d. Alright, so now we have two formulas where you have two variables. This just turns into a system of equations. So set these up, you'll have a sub 1 plus 2d equals 94. Then you'll have a sub 1 plus 5d equals 85. Now you're probably beginning to see why we teach systems of equations before we teach these, because these do come up in sequences and series also. Alright, so just solve this like you would a normal system. I think it's safe to say we could eliminate the a sub 1s by subtracting the second equation from the first a sub 1 minus a sub 1 is 0. 2d minus 5d is negative 3d, equals your next side. 94 minus 85 is going to be 9, which means d is negative 3. So I found my common difference to be negative 3. Now all I need to do is take that and put this into one of these equations, substitute that d in, and solve for a sub 1, which is easy. I'll take the top equation. So a sub 1 plus 2 times that negative 3 equals 94. So a sub 1 minus 6 equals 94, which means that a sub 1 is going to equal 100. Now I've not only identified my common difference, I've identified the first term from that. And then we can find the general formula for the nth term of the sequence. So a sub n is going to equal my a sub 1, which is 100, plus that n minus 1 times my common difference of negative 3. Let's simplify this. You'll have 100 minus 3n plus 3, which means the explicit formula for the nth term of the sequence is going to be 103 minus 3n. So a sub n equals 103 minus 3n. That's the explicit formula for the nth term of the sequence. And from there, I could find any term of the sequence I wish. Let's do a couple more of these, because these tend to throw people for a loop and trick them. But once you understand what you're dealing with, these really aren't that bad. Okay, so we're given a sub 5 equals 190. A sub 10 equals 115. Okay, so we're given the 5th term and the 10th term. We don't know the first term, we don't know the common difference. But we can find those by setting up systems of equations. First, let's deal with each term one at a time. So a sub 5, according to the formula, is going to equal my a sub 1 plus, now since I'm dealing with the 5th term, I'll put in 5 for n. That would be 5 minus 1 times d. Well, a sub 5 is 190. That means 190 equals a sub 1 plus 4d. Alright, now let's go ahead and deal with our 10th term. So a sub 10 equals a sub 1 plus, we said that we're dealing with the 10th term, so we'll put in 10 for n. That would be 10 minus 1 times d. Well, a sub 10 is 115. That's going to equal a sub 1 plus 9d. Not 90, 9d. Now I think you see where the system formed. So let's set up the system of equations. You'll have a sub 1 plus 4d equals 190, and then you'll have a sub 1 plus 9d equals 115. So let's go ahead and we can definitely eliminate the a sub 1 and just solve for our common difference first. So let's subtract the second equation from the first. A sub 1 minus a sub 1 is 0. 4d minus 9d is negative 5d. That's going to then equal 190 minus 15. That would just be 75, which means d would have to be negative 15. So I've identified my common difference now to be negative 15. We know that. All we have to do now is substitute that into one of these equations and we can solve for the a sub 1 term. Let's go ahead and take this top equation. So a sub 1 plus 4 times my common difference of negative 15 equals 190. So a sub 1 minus 60 equals 190. That means my first term, a sub 1, is 250. So now not only do I know my common difference, I also know my first term, a sub 1, to be 250. So let's go ahead now form the general formula. So a sub n is going to equal that first term, 250, plus that n minus 1 times that common difference of negative 15. Simplify this, you'll get 250 minus 15n plus 15, which means my final simplified answer is going to be 265 minus 15n. That would be the general explicit formula for the nth term of the sequence. A sub n equals 265 minus 15n. And let's do one more. And then we'll be done with the lesson. So we're given a sub 5 equals 16. A sub 14 equals 38.5. This one's definitely not as nice, is it? But we know the fifth term and we know the 14th term. We do not know the first term or the common difference. And I'm sorry I erased the formula. Let me put that formula back up. A sub n equals a sub 1 plus the quantity of n minus 1 times d. There we go. There's our general formula for the arithmetic term. Now, we'll work from there. So, since we don't know the first term or the common difference, we're going to have to form another system of equations. So, start with your fifth term. So, a sub 5 is going to equal our a sub 1 plus, since we're dealing with the fifth term, put in 5 for n, so that'd be 5 minus 1 times d. Well, our fifth term is 16, that's going to equal a sub 1 plus 4d. Now let's deal with the 14th term. So a sub 14 is going to equal a sub 1 plus, now we're dealing with the 14th term, so put in 14 for n, that'd be 14 minus 1 times d. Our 14th term was identified to be 38.5. That would equal a sub 1 plus 13d. Now you see where we have our two systems of equations. So let's go on ahead now and set up our system. We'll have a sub 1 plus 4d equals 16, and then a sub 1 plus 13d equals 38.5. Again, I think it's safe to say we can go ahead and eliminate our a sub 1 by subtracting the second equation from the first. If you do that, the a sub 1's cancel out. 4d minus 13d equals negative 9d. That's going to equal 16 minus 38.5. Well, that should be negative 22.5. So then we should be able to get our common difference here very shortly. Let me just divide the result here. So I need to take 22.5 divided by 9. I get 2.5. So now I have my common difference to be 2.5. Alright, so since I found my common difference, I can just take that, put that into one of these equations, and solve for my a sub 1. As for me, I'm opting for the top one, the a sub 1 plus 4d equals 16. So a sub 1 plus 4 times that 2.5 equals 16. That means a sub 1 plus 10 equals 16. So a sub 1 equals 6. So now we found the first term to be 6. Since we know the first term and the common difference, we can find the general explicit formula for the nth term of the sequence. So a sub n is going to equal that a sub 1, which is 6, plus that n minus 1 times my common difference of 2.5. Let's simplify. You'll have 6 plus 2.5n minus 2.5, which means my final answer for the simplified formula would be a sub n equals 2.5n minus 3.5. Sorry, plus 3.5, excuse me. So a sub n, the explicit formula, ends up being 2.5n plus 3.5. Okay, so that's it for this lesson. Next lesson, we're going to get into arithmetic series. There's ways of solving arithmetic series also that are pretty nice, and there's shortcuts for that. So I hope everyone has a great day. Take care.